In this video, I'm going to show you some of the Arduino tips. We are going to understand what is a preference file and how to find where the compiled hex files are, and how to change the sketchbook location, and an open source tool called XLoader, which is used to load the hex file to Arduino. There are a couple of interesting things in Arduino IDE, and which will be very interesting for the people who are doing this Arduino programming for the first time. So I have got the IDE running, and I've just loaded the very basic example called the blinking. If you go to the basics and say blink, so this program is something similar to the Hello World program, which we all use in doing the C programming. So this program just blinks an LED. I'm not going to go into the Arduino programming in these videos. So let's talk about this IDE. So IDE lets you create Arduino programs. These days there are so many other IDEs you can use to create Arduino programs. In fact, the Microsoft Visual Studio also has a plugin to do Arduino programming. However, most of my projects I use only this Arduino IDE. So the first toolbar here, this for compiling. So when you hit your C program, or the C++ program is compiled into the machine code, and there are some useful information at the bottom of this IDE. So what the second line says is, this program when compiled takes 928 bytes of memory. You know, Arduino microcontroller has a limited main memory, which is 32 kilobytes, and most Arduino developers, they keep an eye on this size. You cannot fill up entire available memory space. So this memory space here, what you see, the 32,000 bytes, this is the EEPROM, means this way the program is stored. There is one more memory in Arduino, that is the RAM, where all our variables, all the computations and read and write happens. And we have to be very careful with the second memory, that is the dynamic RAM, which is 2 kilobytes in case of Arduino Nano or Uno. If you want more memory, you have to go to the Arduino Mega. So it all depends on what kind of projects you're doing. So I have done a few projects which requires more memory. Say for example, I had a RFID with the network card, and with the timer, with the buzzer, LEDs. There's so many things are put in this in a single product, which the 2 kilobytes was not enough, because when you start using the network card with Arduino, network card needs more free memory space. So here what you can see is the compiled size is 928. That's fine. I'm not too much concerned here because I still have got 30 kilobytes left. The next line says 9 bytes of the dynamic memory is used, leaving 2039 bytes for local variables. So this is where all the variables you create in your Arduino programs are stored. So this is a very useful information for Arduino developers. So the compilation, by definition, the compiler compiles your C program to machine code. So somewhere in my file system, the machine code file must exist. And when you click this upload button, so this loads the machine code, which in Arduino community is called as a hex file. So this second button loads the hex file to the Arduino or microcontroller. So that's what just happened. But there is no enough information, but we are going to say how to get more information about what's happening in the background. The first thing you have to do is go to the file, go to preferences, and in here I have already used the first option here, which you can choose to change where you want to keep all your Arduino programs. So if you don't change this, it will be pointing to somewhere in your documents folder. Every time I do a new project, I always have a separate folder and I will point this to that folder. So if you scroll down, you can see this is like a hyperlink. It says more preferences can be edited directly in this file, and this is where the preferences text file is stored on my machine. So this goes into my user profiles. So my login is called development, app data, local, and so on. So if you click this, so this is the folder. So as you can see here, this is the folder where it's stored, and we are interested in the preferences. So double click and this opens up in a notepad. There are so many options here. I think the best place is the internet, and you can see there are all my files which I have opened so far is also recorded. And I'm not going to go through this in detail because I myself don't know, but there are some options which you can change, which I'm going to do pretty soon. So this is something worth checking. If for example I just saw something over here. See, every entry in this preferences file has got a name and a value pair. This is the name. The name has got build.verbose, so something, it uses a dot notation followed by the value, whether it's a true or false, or it can be some decimal number. And if you remember, I just spoke about the sketchbook location, which is pointing to my folder. So this is where the settings are stored. Probably you can also see something like the COM port, what's the last COM port I am using, and the baud rate of the serial port. Okay, there are so many things which you can, I'll leave that to you. Probably internet is the best place to understand that. So what I'm going to do now is just play with this show verbose output during compilation and the loading. So I'm going to put a tick on the compilation first, and if you click OK, and let's go and compile and see what happens this time. You can see there's so many messages scrolling through here, and for some probably developers, they would be interested to know what's happening here. But I would like to show you, well, we don't have to go through each and every line. So what we are trying to do now is to find out where is the machine code or hex file of this program is stored. So if you scroll down, probably the last line, so it says, so you should look for the hex file. If you see the last line, it says, this line, it says copy something dot elf to blink ino.hex file. So I'll be interested in this. I'm going to copy this folder, and I'm going to open that in my Explorer. Okay, and this is where the hex file is stored. So you'll be interested in the hex file. It creates so many intermediate files which will not be worried now, but I'll be interested in this blink, this name of the program, and hex file. So I'm going to right click, and you can open that in your notepad and check what it is. So probably send to I've just opened that hex file in my notepad++, and as you can see, this is some kind of a a machine code that's get loaded into the Arduino microcontroller. Probably there could be some more processing happening when this is uploaded. So this just you got some flavor of what exactly is happening when you compile the program. So this time I'm going to open our sample or example of PN532 libraries. I'm going to, if you remember, we have been trying this ISO IDE. Okay, so I'm going to compile, and just want to remind you that before you compile, you make sure you got the board selected. I have noticed the compiled hex file for Uno and Nano are the same, so that's what I noticed. So here again, there's so many, because a bigger file probably takes more time. And again let's go and see, probably it will be in the same folder. So this time all my files are copied to a different folder. Looks like every time you compile, it goes in a different folder. Just going to copy that. Yeah, this is a different folder. Probably that's what the Arduino IDE does. And you got the hex file here. So we know now where the hex files or the compiled files are stored. Let us see what happens when I upload this program. So this time I'm going to go to preferences, and just like we had a verbose settings for compilation, I'm also going to do for the upload. And don't think there is any place you can clear the screen. So let's right click now. So I'm going to upload this file. So here got some error message saying that okay, there is something, or I don't know whether it's an error message or something different. Oh, it's not error message. Okay, so there's some kind of a lot of verbose information is here. So looks like it's trying to flash the memory with the same hex file, if you see here, and probably is verifying it. It says 5 and 1/8 bytes are flash verified. Okay, so what this upload command is doing is take the hex file, probably it will do some kind of a linking or something like that, and it's maybe some kind of a processing or pre-processing, and it's trying to upload the file. So this is the file eventually that gets copied to the Arduino microcontroller. So what do we do if I want to keep all these files in my own folder? So we do this when we have to assume that we have written an Arduino program and we don't want to give the source code to the user. So we want to send only the hex file, and we know where the hex files are stored. They all get into some folders like this. But just like we kept the source code in one place, I also want to keep this build or the hex files in some a known folder. So what I'm going to do now is I'm going to show you how to change that. So not in here. So if you know that this is our folder we have been following since from video 1. So I have created a folder called the build folder, and I want all these hex build to be done everything here. So I'm going to copy this and I'm going to make some changes to the Arduino IDE. So to do that, you can close. I'm going to open this one. So I'm going to open this preferences again and go to open the preferences.txt file, double click. So I know by looking on internet, I know what changes I have to do. So we'll go and open that preferences.txt file, and you have to add a line called build.path and pointing to the folder. But there is a small issue here, so I cannot make a changes here and go back to here and click OK. The reason is, as soon as I make a change, um, as soon as I close this window, IDE is going to override. You're going to lose all the changes you did. So what I'm going to do now, I'm going to close Arduino. I know what changes I have to do now. Open the preferences file. Yeah, this is here. So if it's not here, then you have to add this. And now I'm going to go and open the Arduino IDE. So I'm going to compile. This time somewhere down you can see that there is references to our build folder, and if you go to that actual build folder, you should see that, oh, it's called a blink. Yeah, that's one. Probably I must have compiled the blink program. Let's go and compile the PN532 example. Yeah, so I'm going to compile. You can have a look on what's happening here. Looks like every time you compile, it is going to delete the existing or the entire directory file structure or the files, and is going to populate with all these new files. So there's so many things. Probably you can go through this. You can see that all CPP files are compiled to object files. So it looks like all the files that are libraries that are used in our program will get compiled here. So it's interesting to just play around with the structure, but we'll be more interested in the hex file. So this is the hex file. So if you have to give your compile code to a friend or a user, you can just tell them, you can just email this hex file to them. So like we did before, I can open this in Notepad. So this is the Notepad. Just there's nothing you can do here. I don't think it's advisable to change anything, but you can make out some kind of a structure here. Looks like all these hex files ends with all 00s and 1F. Next I'm going to show you how to compile a source code given to you by some other developer. So I have got a source code here called RFID Learners Kit source code. If you double click, now I got two projects. One is for PN532, other is for so it doesn't matter what this source code is, but looks like because there is a libraries folder here, looks like this entire folder is the sketchbook. So assume that I want to compile this. So I got a source code and compile this. So I'm going to show you all the things we end up doing. The first thing I'm going to do is change the preferences and change the location of this sketchbook. So I'm going to set this as this. So every sketchbook must have a libraries folder. Open, and after that, if you go to the sketchbook, you can see all these Arduino projects. So I'm going to open the one with the RFID Learner PN532, and this is a program I have written long ago. It has got so many tabs here, and you can create tabs like this as well. So if you go here and click on new tab, that's what part of the programming. So I'm going to show you how to compile. So this I'm going to compile, and we're going to load this in two different ways. So first let me compile. Probably now while this is happening, you can, if you don't like, you can take out this compilation and upload. I'm going to just remove them. So we can go and see what's happening in the build folder. So look at that, it's started adding the files. So the compiling is done. So one thing you have to keep in mind, even the smallest, every program you compile, they are going to be of the same size. So more or less are probably the same size. Okay, so we just compiled it. Now I'm going to show what happens. I've already got this Arduino Nano with the PN532 and LED connected. I'm going to show that now. If you look at this, some of the information about this program, you can see that this program takes around 16,144 bytes out of 32, and it has taken 913 bytes out of 2K. So I'm going to upload this. And if you remember, in all my previous videos I used to use an LED along with the PN532 and Arduino, and this program what I just compiled is a kind of a learning program used to understand the structure of various RFIDs. I've used this LED just to show whenever there's an error. Probably you can also connect a buzzer, and you can also there's something it's very good for user to know what's happening. For example, if you're reading, you can keep on flashing this green light. Okay, so that was the reason why I used to have this LED module in all my connection diagrams. So I'm going to show you what this program does. This is a very interesting program to learn various RFID, all the RFIDs I used to show in my previous videos. So this I've also written a Windows desktop application that communicates with the Arduino Nano to read and write. So this is the desktop program I mentioned about. So I'm going to show you quickly now what this software does. And connect, as you can see, every time I communicate I'm making this green LED flash. So I'm going to keep, say for example, the MeFair 1K, and say select, and I'm going to use an option called dump. So as you can see, the green light has been flashing. So that's kind of a information to the user that there's something is happening within this microcontroller. So this software teaches you the structures of all these tags I have used except the DeskFire. So this is what it is. You can also try this ultralight. Say stop and try the ultralight. So all the tags I have shown in my previous videos. You can understand the various structure. This is the 4K. So I've got so many videos as well in YouTube. You can see them. They shows you how to understand and use this software as well. So this is 4K, and I got the ultralight EV1. So this EV1 is a very interesting tag. It comes with the password protection as well. You can learn how to work, and there's some there are lots of documentation on internet as well. You can study that. Likewise, you got ntag 213. So what we did just now is I had the source code, we compiled it, and we uploaded the hex file into the Arduino. What if you have got just a hex file, you don't have the source code? So how do you load the hex file into this Arduino microcontroller? So in order to do that, there is an interesting open source software which I'm going to show now. I'm trying this last tag ntag 203, and okay. So I'll show you how the other. So for example, if I try to select without a tag, as you can see, I'm showing a red light. Okay. So any project you have in Arduino, it's good to keep the RGB LED, so that you get various options. You can also use a blue color to indicate some kind of a some error conditions or some scenarios. So there's a program called XLoader, which I've shown here. You can go to this URL and download a copy of that. This is an interesting program which you can use to upload a hex file into the Arduino connected to some COM port and with certain baud rate. So it's a very straightforward program. You can download these zip files and unzip, and I've done that. I'm going to show you the content of that folder in a minute. So as I did before, all the downloads I've done, I've kept in one single folder. So I've got the X folder, I've unzipped it, I've also moved that unzip folder into separate folder here. So this is the application you're going to run, and it's a very interesting, very clever program, I would say, and it's also easy to make a program like this, because all these files, what you can see here, they're all part of this Arduino IDE. So we will keep that for some other video. So I'm going to run this XLoader. So you can see here, so here we are going to choose where is the hex file. You're going to choose the kind of a device. At present it supports the Mega, Nano, Uno, and the Mega 2536, and in our case it is a Nano with the 328, and you have to choose the COM port. Mine is connected to COM3, and I would leave this default. So you're going to choose the hex file. So we already know where the hex file is. Say we have got if you remember, this is where all our hex files are loaded. I'm going to choose the first one. There's something called with the bootloader as well, which I've not used this, but I'm going to choose this one. Open. Then you can see when you click on upload, you should be able to see that the Arduino, whenever there's a data through RX and TX, you can see a flashing light. You can see that there's something going on there. Looks like it's uploading, and yeah, it's uploaded, and I know that it's working because in my program, as soon as the program starts, I'm making this green light on. So you can use this XLoader. I made some videos in YouTube long ago, but it's a very simple software, as you can see here. The only thing you have to be careful is choose the proper board. If you choose the wrong board, I've seen it, the program sometimes it hangs. You just have to restart again.